Nutrients are components in foods that an organism uses to survive and grow. Macronutrients provide the bulk energy an organism's metabolic system needs to function, while micronutrients provide the necessary cofactors for metabolism to be carried out. Both types of nutrients can be acquired from the environment. Micronutrients are used to build and repair tissues and to regulate body processes, while macronutrients are converted to and used for energy. Methods of nutrient intake are different for plants and animals. Plants take in nutrients directly from the soil through the roots and from the atmosphere through the leaves. Animals and protists have specialized digestive systems that work to break down macronutrients for energy and utilize micronutrients for both metabolism and anabolism in the body. Organic nutrients consist of carbohydrates, fats, proteins, and vitamins. Inorganic chemical compounds such as dietary minerals, water, and oxygen may also be considered nutrients. A nutrient is considered essential if it must be obtained from an external source, either because the organism cannot synthesize it or because insufficient quantities are produced. Nutrients needed in very small amounts are called micronutrients, while those needed in large quantities are called macronutrients. The effects of nutrients are dose-dependent. Shortages are called deficiencies. Types of nutrient. Macronutrients are defined in several different ways. The chemical elements humans consume in the largest quantities are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, or CHNOPS. The classes of chemical compounds humans consume in the largest quantities and which provide bulk energy are carbohydrates, proteins, and fats. Water and atmospheric oxygen also must be consumed in large quantities, but are not always considered food or nutrients. Calcium, salt, magnesium, and potassium are sometimes added to the list of macronutrients because they are required in large quantities compared to other vitamins and minerals. They are sometimes referred to as the macrominerals. Substances that provide energy. Carbohydrates are compounds made up of types of sugars. Carbohydrates are classified by the number of sugar units: monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Proteins are organic compounds that consist of amino acids joined by peptide bonds. The body cannot manufacture some of the amino acids. The diet must supply them. Proteins in nutrition are broken down through digestion by proteases back into free amino acids. Fats consist of a glycerin molecule with 3 fatty acids attached. Fatty acids are unbranched hydrocarbon chains, one connected by single bonds alone or by both double and single bonds. Fats are needed to keep cell membranes functioning properly, to insulate body organs against shock, to keep body temperature stable, and to maintain healthy skin and hair. The body does not manufacture certain fatty acids and the diet must supply them. Although alcohol provides energy, and can thus be compared to macronutrients, it is not a substance that is essential for normal function. The acetic acid in vinegar also provides a similar amount of energy per gram, but again, it is not a nutrient because it is not essential for normal function. Fat has an energy content of 9 kilocalories per gram, proteins and carbohydrates 4 kilocalories per gram. Ethanol has an energy content of 7 kilocalories per gram. Substances that support metabolism. Dietary minerals are generally trace elements, salts, or ions such as copper and iron. Some of these minerals are essential to human metabolism. Vitamins are organic compounds essential to the body. They usually act as coenzymes or cofactors for various proteins in the body. Water is an essential nutrient and is the solvent in which all the chemical reactions of life take place. Plants absorb nutrients from the soil or the atmosphere, or from water, an exception of the carnivorous plants, which externally digest nutrients from animals before ingesting them. The chemical elements consumed in the greatest quantities by plants are carbon, hydrogen, and oxygen. These are present in the environment in the form of water and carbon dioxide. Energy is provided by sunlight. Nitrogen, phosphorus, and sulfur are also needed in relatively large quantities. Together, the Big Six are the elemental macronutrients for all organisms, often represented by the acronym CHNOPS. Usually they are sourced from inorganic or organic compounds, although elemental diatomic molecules of nitrogen and oxygen are often used. Other chemical elements are also necessary to carry out various life processes and build structures. See fertilizer and micronutrient for more information. Some of these are considered micronutrients in certain organisms. The mnemonic C. Hopkins Cafe-MG is used by some students to remember the list as carbon, hydrogen, oxygen, phosphorus, potassium, nitrogen, sulfur, calcium, iron, and magnesium. Silicon, chloride, sodium, copper, zinc, and molybdenum are sometimes also included, but are in other cases considered micronutrients. Essential and non-essential nutrients. Nutrients are frequently categorized as essential and non-essential. Essential nutrients. Essential nutrients are unable to be synthesized internally, and so must be consumed by an organism from its environment. Non-essential nutrients are those nutrients that can be made by the body. They may often also be absorbed from consumed food. The majority of animals ultimately derive their essential nutrients from plants, though some animals may consume mineral-based oils to supplement their diet. For humans, these include essential fatty acids, essential amino acids, vitamins, and certain dietary minerals. Oxygen and water are also essential for human survival, but are generally not considered food when consumed in isolation. There are no essential carbohydrates. Animals can synthesize all the types of carbohydrates needed for growth. Humans can derive energy from a wide variety of fats, carbohydrates, proteins, and simple chemicals such as ethanol and acetic acid. Non-essential nutrients. Non-essential nutrients as substances within foods can still have a significant impact on health, whether beneficial or toxic. For example, most dietary fiber is not absorbed by the human digestive tract, but is important in maintaining the bulk of a bowel movement to avoid constipation. Interest has recently increased in phytochemicals, which include many non-essential substances which may or may not have health benefits. Deficiencies and toxicity. An inadequate amount of a nutrient is a deficiency. Deficiencies can be due to a number of causes including inadequacy in nutrient intake called dietary deficiency, or conditions that interfere with the utilization of a nutrient within an organism. Some of the conditions that can interfere with nutrient utilization include problems with nutrient absorption, substances that cause a greater than normal need for a nutrient, conditions that cause nutrient destruction, and conditions that cause greater nutrient excretion. Nutrient toxicity occurs when an excess of a nutrient does harm to an organism.